Hello students, myself Dilip Udani, Assistant Professor at LJ Institute of Engineering and Technology. And the name of the unit is Ordinary Differential Equation of Higher Order. And in this unit, the topic is non-homogeneous linear ordinary differential equations of higher order with constant coefficients. So in this topic today I will teach you case number 3, that is how to find out pi when q of x that is equals to x raised to m. So let's start. So we are going to discuss case number 3, when q of x that is equals to x raised to m, where m is greater than 0. Now, as all of you know that the formula of pi is 1 upon function of d q of x. So in case number 3, what we will do, we will just make 1 plus function of d from this f of d. So we will write down 1 plus phi of d the whole raised to 1, and we will replace q of x by x raised to m. Then after we will write down 1 upon x as x raised to minus 1. So by applying the same concept, we will write down 1 over 1 plus phi d the whole raised to 1 as 1 plus phi of d the whole raised to minus 1 x raised to m. Now we will expand 1 plus phi of d the whole raised to minus 1 up to d raised to m, because here we have been given x raised to m. Then after we will apply that particular operator on x raised to m. Just keep in mind 1 plus x the whole raised to n, that is given by 1 plus n into x raised to 1 plus n into n minus 1 by 2 factorial x square plus n into n minus 1 into n minus 2 by 3 factorial into x cube, and so on. You just remember these formulas. I will write down for you. 1 minus x the whole raised to minus 1, and its expansion is given by this formula, that is 1 plus x square plus x cube, and so on. And the expansion of 1 plus x the whole raised to minus 1, that is 1 minus x plus x square minus x cube, and so on. Similarly, just remember the expansion of 1 minus x the whole raised to minus 2, that is 1 plus 2x plus 3x square plus 4x cube, and so on. And finally, just remember the expansion of 1 plus x the whole raised to minus 2, that is 1 minus 2x plus 3x square minus 4x cube, and so on. Now we will see examples based on this case. That is example number 1. Solve d square plus dy equals to x square plus 2x plus 4 First of all, we will compare the given differential equation, that is this one, with f of dy equals to q of x. So by comparison, we have f of d, that is equals to d square plus d, and q of x, that is equals to x square plus 2x plus 4. Now the general solution is given by this formula, that is y equals to cf plus pi. Now first of all, we will find out cf, that is complementary function, and to find cf we will write down f of d equals to 0, and we will replace d by m to get auxiliary equation. So we have f of m equals to 0. Now in f of d, that is equals to d square plus d, we will replace d by m. So we have m square plus m equals to 0. Now from this equation we will find out the values of m. So first of all, taking m common, so into bracket we have m plus 1, that is equals to 0. So we have m equals to 0, or m plus 1 equals to 0. So we have m equals to 0 or m equals to minus 1. So complementary function cf, that is c1 e raised to 0x, and e raised to 0x is 1, and if you multiply 1 by c1 you will get c1. Then after plus c2, and the value of m is minus 1, so we will write down e raised to minus 1x. So this is the required cf. Now we will find out pi. Pi is given by this formula, that is pi equals to 1 upon f d q of x, and this is equals to 1 upon f of d is d square plus d, and q of x is x square plus 2x plus 4. Now we will take d common from the denominator. So we have d, into bracket we have d plus 1, and this x square plus 2x plus 4 will be as it is. Now we will keep 1 upon d as it is, and we will write down d plus 1 as 1 plus d, and we will write down 1 over 1 plus d as 1 plus d the whole raised to minus 1 x square plus 2x plus 4. Now we will apply this formula of binomial theorem, that is 1 plus x the whole raised to minus 1, and that is 1 minus x plus x square minus x cube, and so on. Here we will expand 1 plus d the whole raised to minus 1 up to d square only, because the maximum power of x is 2. So this is equals to 1 over d, into bracket you can replace x by d in this expansion to evaluate 1 plus d the whole raised to minus 1. So we have 1 minus d plus d square, and we will eliminate the terms from d cube onwards, as d cube of x square will become 0, and this one x square plus 2x plus 4 as it is. Now we will apply 1 minus d plus d square operator on this function, that is x square plus 2x plus 4. So 1 upon d will be as it is, multiplying 1 by x square plus 2x plus 4. So we have x square plus 2x plus 4, then after minus d of x square plus 2x plus 4, and finally we have plus d square of x square plus 2x plus 4. So this is equals to 1 upon d. We will write down this one function as it is, that is x square plus 2x plus 4. D of this function, it means derivative of this function. So minus sign. Now derivative of x square is 2x plus 2 will be as it is, derivative of x is 1 and 2 into 1 is 2 and 4 is a constant value, so its derivative is 0. Then after plus sign, now we have to find out double derivative of this function. To evaluate double derivative, first of all we have to find out single derivative, and single derivative, that is this one, that is 2x plus 2. Now again we will differentiate 2x plus 2 with respect to x to evaluate d square of this whole function. So derivative of 2x, 2 will be as it is, derivative of x is 1, so 2 into 1, that is 2, and this 2 is a constant value, so its derivative will become 0. Now we will simplify this result. So this is equals to 1 over d, this is x square plus 2x plus 4. Now applying minus sign on these two terms, so we have minus 2x minus 2 and this is plus 2. Now minus 2 plus 2 will cancel out, plus 2x minus 2x will cancel out, and 1 upon d, that is nothing but integration. Now we will integrate x square plus 4. Now integration of x square according to the formula, integration x raised to n dx, that is x raised to n plus 1 over n plus 1, so that is x cube by 3. Then after plus 4 is a constant value, and integration of 1 with respect to x, that is 4x. So this is required pi. At last we will write down general solution, that is y equals to cf plus pi. Cf is c1 plus c2 e raised to minus 1x plus pi is x cube by 3 plus 4x. So this is the required general solution. Now we will see example number 2, that is solve d square plus 16y equals to x raised to 4 plus e raised to 3x plus cos 3x. Actually this problem is a combination of case number 1, case number 2 and case number 3. So first of all we will compare the given differential equation with the standard form f of dy equals to q of x. So by comparison we have f of d, that is equals to d square plus 16, and q of x, that is equals to x raised to 4 plus e raised to 3x plus cos 3x. Now the solution is given by this formula, that is y equals to cf plus pi. So first of all we will find out cf, that is complementary function. To find cf we will write down f of d equals to 0. So we will replace d by m. So we have f of m equals to 0. Now in f of d equals to d square plus 16 we will replace d by m. So we have m square plus 16 equals to 0. So we have m square equals to minus 16. So we have m square equals to 16 into minus 1, and minus 1, that is nothing but I square. So we have m equals to plus minus 4i. So the real part is 0 and the imaginary part is 4. Now based on this complex number we will write down cf. So cf, that is equals to c1 e raised to 0x cos 4x plus c2 e raised to 0x sin 4x. But e raised to 0x is 1. So we have cf, that is equals to c1 cos 4x plus c2 sin 4x. Now we will find out pi, and pi is given by this formula, that is pi equals to 1 upon f of d q of x. So 1 upon f of d, that is d square plus 16, and in this case q of x, that is x raised to 4 plus e raised to 3x plus cosine of 3x. Now we will apply this operator on all the three functions. So we have 1 upon d square plus 16 x raised to 4 plus 1 upon d square plus 16 e raised to 3x plus 1 upon d square plus 16 cosine of 3x. Now from this d square plus 16 we will take 16 common. So we have 16 common, so 16 upon 16, that is 1 plus d square by 16, this is x raised to 4. Now think about case number 1 when q of x is e raised to x. So what we will do, we will just replace d by a. Here we will replace d by 3. So we have 1 over, if you replace d by 3, so it will become 3 square, and 3 square is 9, 9 plus 16, that is 25 e raised to 3x. Now think about case number 2, when q of x is cosine of ax plus b, we will replace d square by minus a square. So in this case we will replace d square by minus 3 square, and that is minus 9. So this is equals to 1 over, if you will replace d square by minus 9, so it will become minus 9 plus 16, and minus 9 plus 16, that is 7. So 1 upon 7 cosine of 3x. Now we are going to simplify this result only, and we will write down 1 over 1 plus d square over 16 the whole raised to 1 as 1 plus d square over 16 the whole raised to minus 1. So this is equals to 1 upon 16 1 plus d square over 16 the whole raised to minus 1 x raised to 4 plus 1 upon 25 e raised to 3x plus 1 upon 7 cos 3x. Now we will apply the binomial theorem to evaluate this function. Just keep in mind this expansion 1 plus x the whole raised to minus 1, that is nothing but 1 minus x plus x square minus x cube and so on. To expand this function, what we will do, in this expansion we will just replace x by d square by 16. So this is equals to 1 over 16 into bracket, this one will be as it is, this minus sign, replacing x by d square by 16, then after plus, replacing x by d square by 16, so it will become d raised to 4 and 16 square, that is 256, and if we replace x by d square by 16 over here, so this one will become d raised to 6. So we will not write down the term of d raised to 6 because d raised to 6 of x raised to 4 will become 0. So this is x raised to 4 and these two terms will be as it is, that is 1 over 25 e raised to 3x plus 1 over 7 cosine of 3x. Now this is equals to 1 over 16. Now multiplying 1 by x raised to 4, so we have x raised to 4, then after minus 1 over 16. Now double derivative of x raised to 4. First of all, think about single derivative of x raised to 4, that is 4x cube. Now again differentiate 4x cube, that is 12x square. So we will write down 12x square over here, then after plus 1 over 256, and 4 times derivative of x raised to 4, that is 4 factorial, and 4 factorial, that is 24. And we will write down these two terms as it is, that is 1 over 25 e raised to 3x plus 1 upon 7 cos 3x. Okay, now we will simplify this result. So this is equals to 1 over 16. This is x raised to 4. Then after 12 by 16, dividing numerator and denominator by 4. So we have 3x square by 4. Then after 256, that is 2 raised to 8, and we will write down 2 raised to 8 as 2 raised to 3 multiplied by 2 raised to 5, and 2 raised to 3, that is 8. Now divide 24 by 8, you will get 3, and divide it by 2 raised to 5, that is 32, and these two terms will be as it is, that is 1 over 25 e raised to 3x plus 1 over 7 cos 3x. So this is the required pi. Now the general solution is y equals to CF plus pi. At last you have to write down only CF and pi. So this is the required general solution of the given differential equation. So in today's lecture we have discussed case number 3, that is how to find out pi when q of x, that is equals to x raised to m, where m is greater than 0. And we have gone through 2 examples based on this topic. Thank you for watching this video.